dynamically shared on the infrastructure. So that if I have an online application that's being hit extremely hard by a set of users, both internally and externally, that application should expand its footprint to consume larger bandwidth resources. Similarly, if I have applications that are not being used but are still online, then what we're moving to would be less application infrastructure being utilized. So there was a question that was posted around what kind of numbers are you seeing, and I do have some of the numbers at the end of the presentation, so I will get back to that question in a little bit. And I also will come back to the security question. But I just want to kind of give everybody just a little bit more of a view of what this looks like, okay? Closed loop model enables you to build dynamic infrastructure that is shared. Okay? If the applications that are running on this shared cloud computing infrastructure can share their analytics, be instrumented to share, kind of key data elements of what those applications are doing, and you can build policy models, you are going to raise utilization, you're going to increase the performance of applications, the user experience is going to be great. It's really a key kind of goal that folks are going to get to. Now, I will say this is not the starting point for a lot of organizations, especially the enterprise, right? Automating the provisioning of applications through self-service, automating the development processes through self-service and templatized approaches. Kind of this is where the starting points for cloud computing in the corporate data center are going to be. But this picture, I think, represents where every single enterprise IT organization is going to want to get to. Also, what we're seeing is that we can also build calendar-based models, so we can distribute those applications, or even business criticality and priority. So this whole notion of instrumenting applications, sharing dynamic infrastructure provides a lot of models and a lot of versatility and a lot of improvements to the way that the enterprise IT organization can offer a cloud out to both their internal and external customers. So, this is our kind of high-level conceptual model for for cloud computing for the corporate data center. I think that what you see is high-performance IP backbone at the bottom. I think that we see a virtualization being widely deployed, a runtime infrastructure that has both brokering, orchestration, a central repository for all of your services or a services catalog, the ability to manage policies, reporting, ability to plug in other types of asset management, other types of provisioning technologies for both networking and storage, a myriad of services such as SaaS services, which are kind of more software as a service, PaaS services, which we call platform as a service to help you build applications, or just infrastructure as a service, which is the ability just to provision on-demand compute, storage, and networking resources. And then this whole notion of self-service at the top, where you have an online web presence, you have control over users and permissions and workflow, and significant security. So. And again, provisioning applications onto these virtual environments is a critical component of cloud computing for the enterprise. I think a lot of folks are talking about this. But it needs to be highly automated. It needs to manage, it needs to be self-managing so that if there are no available virtual machines, that you can control the virtual machine infrastructure so that virtual machines are created dynamically. You need to be able to control the application repository so that these applications can be provisioned dynamically when needed. You need to be able to shut these virtual machines down on a regular basis so that you not have this notion of virtual sprawl. I think this is a critical component. I think nobody would argue there as well.